Welcome to this video about the FastFlood.org website. This is a new groundbreaking model for really rapid flood simulation and mitigation design that you can use in your web browser. It's a free tool, and in this video I'd like to explain to you a bit how it works and how you can use it yourself. So let's have a look. When you go to the website, you're welcomed by a greeting message, and there's a tutorial and a quick start where you can find some basic overview about the methodology and as well about how to use the software. Let's close this. Well, let us go to an interesting study area and do a flood simulation. Now there's a lot of options here, but the basic start is selecting the automatic download tool, dragging an area, and selecting the spatial resolution that you want to use for the modeling. In this case, I'm going to go with 20 meters. Under the hood, the model automatically downloads 30-meter resolution SRTM data. Keep that in mind. You might note that I'm selecting an area which encompasses a catchment, and the reason is I'm going to do flood simulation from a rainfall event. That means I have to simulate an entire catchment. Otherwise, I would have to find boundary conditions for incoming water through rivers. Well, once we've downloaded the elevation model, we can go ahead and press the Simulate button to get an idea of our area. And that's it. We have our first flood simulation done. You can zoom in a little bit and see the overlay with the villages and the houses here. Of course, we still don't know what kind of event we're simulating. Well, the default rainfall intensity is set at some typical value, but you have to adapt this for your own area, of course, because this is not going to be valid anywhere. So I'm going to change the rainfall intensity from 30 meters to something that's more typical for a tropical hurricane. In this case, maybe tropical cyclone Maria that went over in 2017. So let me take an intensity of 90 millimeters an hour with a duration of 4 hours. So I'm going to press Simulate again, and there are results. Now, if I'm interested in seeing the actual flow heights, I can use the Shift button to see the water height at various locations, as well as the elevation model. Now, if you're not interested in using SRTM data, you can alternatively download your own data. Here I load an elevation model for the same area, and it loads and produces the hillshade for me to see. Again, I can set the same precipitation event, press Simulate, and we can see that we see the results rather quickly. Now, a word of warning for this tool. It allows for really rapid flood simulation and estimation of flood impact, and I'll show you some really cool uses of that in a minute. However, this ease of use doesn't mean that you shouldn't be careful with your assumptions with this model. It does make some assumptions and approximations in calculating the flood map, and you have to keep this in mind and know what you're doing. Please read the manual thoroughly, and if you're in doubt, contact us for more help in how to use this tool in an appropriate manner. So let's add some more detail to this simulation for now. I can automatically download land cover information from the Copernicus 10-meter resolution world cover database. If I select the download button, it will automatically download the relevant geodata, show me the Manning's N map that results. So the Manning's classes are shown in the menu. There's 11 classes in total, and each of them has a default Manning's coefficient. The map here shows the class values. Now, let me remove this map so we can see the flood map itself. Another option we can use is the infiltration. We can upload our own infiltration rate map, but we can also automatically download soil information from the SoilGrid's global soil database and then estimate infiltration rates based off that. So that's done, and it's now estimated the infiltration rate for this area as well. Now we can run the simulation again, and we should have a better idea of how the physical processes now interact. If we want more information, we can also see, for example, how each of the land use classes is impacted by the flood impact map. So One of the more useful tools that you can find here is the design of mitigation. So let us zoom in on one of the villages here and see what we can do with these tools. The town that's located in the middle here, called Pichelan, is located between two different streams that floods quite frequently. So let us go to the mitigation editing tool. So we can draw polylines, and these polylines represent barriers for the flow model. So I'm going to add a reservoir here. I can set the height of this feature. Well, let's make this 5 meters for now. To simulate this correctly, in the settings we have to click the option Account for Depressions. Otherwise it's not going to give us correct results. I will press Simulate again, and it correctly estimated that the reservoir would be filled, but it would be too much water and eventually it would overflow. Now you can play around with these parameters, change the height of the reservoir boundary, and even change the position of the points. In real time, see your simulation results adapt. Now there is a shortcut for running the model, which is Shift plus the R key. So again, if I change the location of these reservoir points and press Shift R, it's going to automatically run the model again for me. Another tool here is the polygon tool or the square tool. Now, for now, I'm going to focus a little bit on the northern stream, which does impact some of the houses here. And what we can do is use the paint tool to paint a widened and deepened channel dimension. So I'm going to click here with the paint tool, select the negative value, and that way I can increase the channel depth by about 1.5 meters. So I'm going to stop painting the elevation. You can show the edits at any time using the edits layer. But for now I'm going to simulate the results again. And as you can see, this changed the flood impact by quite a bit. Not by enough, so let us try that again. And this works even further. Similarly, we can also use positive elevation changes to draw more refined reservoir dimensions. So in this case, I'm going to draw a second reservoir here. Give it quite a high feature. Press the Simulate button again, and we see that also this reservoir fills and overflows eventually. This is some of the functionality that is available for free in the FastFlood.org website. Now let's look at a different kind of flood event. For now we looked at flash flooding in a small catchment on a Caribbean island, but let's go a bit to a larger river system. So the second area we will have a look at is an area in northern Italy. What we can do for this river section, for example, is say the following. We will again use the automatic download tool, select our area, and select the high resolution dataset. You can choose also low resolution datasets if you want to have an even faster running model. What we can do at the top here, where the river enters our area, is define a discharge boundary condition and set an associated discharge value. You can either obtain this through modeling or from measurements directly. Now make sure to set the rainfall to 0, and we can have a simulation where we only provide a discharge boundary condition and then see how this discharge boundary condition affects the flow in the model. Now, as you can see, we don't get quite the realistic results that you would expect. That is, we're making too many assumptions here for this kind of simulation. So there's a couple settings that you can enable to improve the accuracy. First of all, there's the option for flat terrain. Second of all, we have a correction for the nonlinear behavior of flow height with respect to discharge. And finally, we can also set the accuracy for the solver to high. As we can see from these new results that have come in, we now get the appropriate flooding behavior that we would expect with such a high incoming discharge. So keep in mind, it's necessary to set the appropriate accuracy settings to get a realistic simulation. Now, if we're interested in exporting these results, we can use the Export tab in the menu to export the flood map, the measures, elevation model, infiltration, manning data, and much more. We can also import edits that we've made earlier. We can import measures, mannings, and data that we've set, etc. If you want to import the elevation data, you can look under the Elevation tab, and a similar case is true for the land cover and rainfall data. Now, there's a couple more options that I would like to talk with you about. One of those is the channel option. You can automatically detect and estimate channel locations and dimensions. Note that this only works for simulations with entire catchments. You can use the calibration tab to also import observation data. At the moment, this is limited to flood extent maps, and you can calculate the error that the model makes to do some calibration. The infiltration, rainfall, land cover tabs always have a multiplier value associated with them, and by changing this multiplier value, you multiply the entire input map for the model. This allows for easy calibration. Thank you so much for watching this video. I hope you found this a useful tool, and you might be able to use it in your repertoire of available modeling software. If you want more information, please contact us. My name is Basti van den Bout from the University of Twente, and you can find my email address on the website as well. Thank you so much.